Hey, Algebra 1, Mr. Catlin here, helping you out with your homework. This lesson actually that we did today could probably extend into helping you with tomorrow's a little bit. There are some slight differences there, but for the most part, it's just kind of practicing the same idea. And in this video, I just want to quickly talk about it if you weren't able to grasp it or you're absent. The whole idea here is whenever we write quadratic equations in their standard form, okay, so whenever we're putting them in ax squared plus bx plus c. Whenever we put them in their standard form like this, and we're coming from factored form or going back to factored form, we've noticed something. Whenever we have the factored form looking like, let's say that we have x plus m and x plus n, we're noticing that if we multiply the m and the n, we'll get the constant. And if we add the m and the n, we'll get the linear term. This is the linear term. This is the constant over here. And this is our squared term. The squareds are going to multiply x times x and give us x squared. But all the other parts, when you fill them out in the diagram, what we noticed was that the last two parts, their product was our constant, and the sum of the two that were at the end of the groups turned out to be the linear term. So if we follow that pattern down here to number 1, we look at 17 and 1. Their product, 17 and 1, multiplied by each other, will be our constant spot, which is here. And their sum, 17 plus 1, 18, will be the linear term, which goes here. Now, this only works whenever the lead coefficient in front of your x's is 1. There are some other complications that can arise whenever that's different, which might show up later in our other practices. Okay, but let's look at this one. This one, I know the standard form. The linear is 9, and the constant is 14. So we're looking for a pair of factors that their product is going to be 14 and their sum is going to be 9. Well, that would mean that this would have to be 7 because 2 times 7 gives us the 14 for the constant, and 2 plus 7 gives us the 9 for the linear term. And on the last two, they just kind of throw some minuses in there, but it's the same idea. All right, this one we need a constant to be 10. All right, so think about what number could I multiply by negative 2 to get a positive 10? That would have to be negative 5. Oh, sorry, I don't have to put the negative there. They already got my minus in front, so I can just write 5. Sorry. So this would be negative 5. Negative 5 times negative 2 gives me a positive 10. And negative 2 plus a negative 5 gives me negative 7. So that's a pretty simple idea there. And then the very last one, you have to come up with both of them. All right. What two factors could I pull out here that have a product of 20, but when I add them together, I get negative 9. So I need two numbers that have a sum of negative 9, and when I multiply them, I get positive 20. Now, to get a negative sum and a positive product, this is going to have to be two negative numbers, as you can see from the minuses that are in front. And so the numbers that I'm choosing, and the order doesn't really matter here, are 4 and 5, because 4 times 5 gives me 20, and 4 plus 5 gives me 9. Now, this works because of what we noticed whenever we did our diagrams, of our FOIL diagrams. So this is a skill that we can use to quickly factor whenever the numbers come out this way, where the ending part has a product and a sum that are in the standard form. Now, this doesn't always work. This is kind of the special case scenarios, but it is a good shortcut if they work out that way where they can be factored quickly and easily. Later, guys.